The ocean is an uncharted frontier on Earth, a world so vast and mysterious that it still holds secrets waiting to be uncovered. Beneath the waves, strange creatures have evolved in isolation, thriving in conditions that seem inhospitable to most life forms. These deep-sea creatures have adapted to survive under crushing pressures, near-freezing temperatures, and complete darkness. But what if these extreme survivors could somehow exist beyond our planet, on distant worlds? One such world is Europa, a moon of Jupiter, which scientists believe harbors an ocean beneath its icy surface. Europa's ocean is buried under a thick layer of ice, but what lies beneath is tantalizingly unexplored. In recent years, the possibility of life on Europa has captivated the scientific community. Could deep-sea creatures like those in Earth's ocean survive in the icy depths of Europa's hidden waters? To answer that question, we must first understand the conditions that make deep-sea life on Earth possible. The deep ocean, which begins at depths of 200 meters, is a dark and hostile environment. The further down we go, the more extreme the conditions become, with pressure increasing by 1 atmosphere for every 10 meters of descent. Temperatures near the ocean floor hover just above freezing, and there is no natural sunlight to sustain photosynthetic life. Despite these harsh conditions, deep-sea creatures have flourished, evolving to rely on chemical energy from the Earth's interior. Hydrothermal vents, located along the ocean floor, release heat and chemicals that support entire ecosystems. These ecosystems are unique in that they rely on chemosynthesis, a process where organisms use chemicals like hydrogen sulfide instead of sunlight to produce energy. Some of the most bizarre creatures on Earth have adapted to these extreme environments, such as the giant tube worm, which thrives near hydrothermal vents. These worms have a symbiotic relationship with bacteria that convert sulfur compounds into energy. They are just one example of how life can adapt to seemingly impossible conditions. Now, scientists are asking a similar question about Europa. Could life exist in its subsurface ocean? Europa's surface is mostly ice, but beneath that thick layer, it's believed that there is a global ocean of liquid water kept warm by the planet's internal heat. The ocean beneath Europa's ice crust could be in constant motion, much like Earth's oceans, driven by tidal forces from Jupiter's gravity. This dynamic environment might create conditions similar to Earth's deep-sea ecosystems. While the surface is freezing, the ocean could be kept warm by hydrothermal vents, much like the ones that sustain life in the Earth's deep ocean. In fact, recent research suggests that these vents could even be more active on Europa due to tidal heating from Jupiter's immense gravitational pull. The same process that heats Europa's core might also create underwater volcanoes, spewing minerals and chemicals into the ocean. These minerals could provide the necessary nutrients for microbial life and possibly larger organisms to survive. Scientists have found evidence that Europa's ocean could have an abundance of organic molecules, the building blocks of life. On Earth, life thrives in similar conditions where organic molecules mix with heat and chemicals. Europa's subsurface ocean could, in theory, support similar ecosystems to the ones found at Earth's deep-sea hydrothermal vents. But how likely is it that deep-sea creatures like those on Earth could survive on Europa? The first challenge they would face is the extreme cold. Europa's ocean is thought to be much colder than Earth's, with temperatures averaging around 10 degrees to 20 degrees. Earth's deep-sea creatures are adapted to life at near-freezing temperatures, but they are not accustomed to the deep freeze of Europa. However, life on Earth has proven incredibly resilient, with organisms like the Antarctic icefish thriving in sub-zero conditions. These creatures have evolved special adaptations, such as antifreeze proteins, to survive in the freezing waters of Earth's polar regions. It's possible that similar adaptations could help life on Europa endure its bitter cold. The second challenge is the lack of sunlight. Most life on Earth relies on photosynthesis, but there is no sunlight beneath the ice of Europa. However, in Earth's deep-sea ecosystems, life does not rely on sunlight. Instead, organisms depend on chemosynthesis, where chemical energy from the Earth's core is used to create food. Europa's subsurface ocean could host similar chemical-rich environments. Researchers believe that Europa's icy shell may crack open in places, allowing mineral-rich water to rise from below. These cracks could act as vents, similar to those found on the ocean floor of Earth, allowing life to flourish in these isolated pockets. But what about the immense pressures on Europa? The pressure in Europa's ocean could be similar to the deepest parts of Earth's oceans, where pressures are more than 1,000 times greater than at sea level. While these pressures would be challenging for many Earth organisms, some deep-sea creatures have evolved to withstand such extremes. For instance, the deepest living fish known to science, the snailfish, can survive under the crushing pressures of the Mariana Trench. These creatures have developed specialized body structures and cellular mechanisms that allow them to function at extreme depths. Europa's creatures would need similar adaptations to survive the intense pressures of their icy ocean. Another major consideration is the availability of energy. Life on Earth relies on energy sources from the sun, but in the deep ocean, organisms have adapted to use chemical energy from the Earth's interior. Europa could offer similar opportunities, with hydrothermal vents on the ocean floor, providing a steady supply of energy for life forms. But how could deep-sea creatures from Earth adapt to these alien conditions? One possibility is that microbes from Earth could colonize Europa's ocean, especially if a meteorite carried them to the moon. In fact, some scientists have suggested that life on Earth might have originated from elsewhere in the solar system, potentially arriving here on comets or asteroids. If such microbes could survive on Europa, they might form the foundation for a thriving ecosystem. It's also possible that Europa could host entirely unique forms of life, evolved independently of Earth's deep-sea creatures. Scientists have long speculated about the existence of alien life in our solar system, but the conditions on Europa make it one of the most promising places to search. Europa is not the only place in our solar system where life could exist. Other moons, such as Enceladus, also have subsurface oceans, but Europa's ocean is considered one of the most likely places to harbor life. Exploring these environments will require new technologies, such as advanced robotic missions that can drill through the thick ice crust. NASA's upcoming Europa Clipper mission will provide the first close-up observations of Europa, searching for signs of water vapor and possibly life. The discoveries we make on Europa could transform our understanding of life in the universe. Europa's oceans might not only harbor microbial life, but potentially more complex organisms adapted to its unique environment. Could deep-sea creatures from Earth survive there? While we may not yet have the answers, the possibility raises profound questions about life beyond Earth. Europa's ocean is one of the most intriguing places to search for extraterrestrial life, and the discovery of life there would revolutionize our understanding of biology. The question of whether deep-sea creatures from Earth could survive on Europa may one day be answered by the robotic explorers we send to the moon. If life can thrive in the darkest, most hostile environments on Earth, it stands to reason that Europa's ocean could host its own form of life. As we push the boundaries of space exploration, Europa may one day reveal that life, in all its forms, is far more adaptable than we ever imagined. Whether microbial or complex, life could be thriving in the cold depths of Europa, waiting for us to uncover its secrets. In the end, the search for life beyond Earth is not just about finding other creatures, but about understanding our place in the cosmos. Europa's oceans may hold the key to answering one of humanity's most profound questions. Are we alone in the universe? The ocean of Europa may be distant, but its mysteries are as close as the next breakthrough in science and technology. As we venture into the unknown, one thing is certain: The search for life will continue to push the limits of our imagination and our reach. We are closer than ever to unraveling the secrets of Europa's oceans. And with that knowledge, we might one day discover that the creatures of the deep, both on Earth and beyond, are not so different after all. The exploration of Europa has only just begun. As we look to the stars, the deep-sea creatures of Earth are showing us the remarkable potential for life in the most extreme environments imaginable. With each discovery, we come closer to understanding the infinite possibilities that life could take across the universe.